Welcome to Cosmic Compass, where we explore the wonders and mysteries of the universe together. Today, let's turn our attention to Mercury, the closest planet to the Sun. At first glance, Mercury might seem like little more than a scorched rock, but hidden in its surface are clues to a fiery past. Billions of years ago, Mercury wasn't just hot, it was melting. Lava flowed like rivers, volcanoes erupted with violent force, and meteors crashing down only made the planet's fury worse. So what happens when an entire world begins to melt? Let's find out. What happens when a planet melts? For Mercury, the closest planet to our Sun, this is not a hypothetical question, it is part of its very history. Mercury is a world scorched by extreme heat. Daytime temperatures can soar to 430 °C, hot enough to rival wood-burning fires. The rocks and dust on its surface endure this relentless solar radiation constantly pushed toward their limits. Now, Mercury is not the hottest planet in our solar system. That title goes to Venus thanks to its thick, suffocating atmosphere, but it is certainly close. Interestingly, the Mercury we see today has cooled considerably compared to its past. There is ice hidden at its polar caps, and geological evidence shows that the planet has contracted over time as its interior cooled. But what about long ago? What was Mercury like billions of years in the past, before it shrank, when its surface was still alive with energy? To answer that, let's travel back through deep time to an era when Mercury's crust didn't just approach its melting point, it crossed it. An era when meteors rained from the skies, when lava flooded through canyons like rivers, and when volcanic eruptions carved massive scars into the planet's crust. This was the time when Mercury was not a quiet, airless rock, but a lava planet. When rock is heated to extreme levels, its solid structure collapses, turning into magma. This is no thin, watery liquid, but a dense, gloopy substance. Its viscosity can be 10,000 to 100,000 times greater than water. Imagine something closer to honey tar or even tomato ketchup, but at unimaginable heat. Not something you'd ever want near your food. Magma forms at temperatures of at least 600 degrees Celsius and sometimes as high as 300 degrees Celsius. For Mercury to have once melted, we know it must have reached at least these extremes. Once magma erupts onto the surface, it becomes lava. And despite being far less runny than water, lava can still travel long distances before cooling. How? Because once its outer skin hardens, it creates an insulating crust. Inside, the molten rock remains protected, free to flow onward. So Mercury, billions of years ago, wasn't just a cracked ball of rock, it was alive with movement. Lava would have flowed like fiery rivers, pooling into basins, smoothing over rough terrain. Volcanoes would have burst from beneath the ground, ejecting molten rock and choking the surface with ash. It is a dramatic vision, but is there real evidence? How can we today look at Mercury's surface and be confident that this violent past is more than just speculation? Let's explore the craters and valleys that hold the answer. One of the clearest windows into Mercury's molten past is a crater called reshaped. Scientists estimate it is relatively young by planetary standards, less than 1 billion years old. Its walls remain sharp and well preserved. But what makes reshaped remarkable is what lies inside. Instead of being rugged and uneven like the surrounding terrain, its floor is strikingly smooth. This is not an accident. Originally, the crater floor would have been just as rough as its edges. So why is it flat today? The answer is lava. Lava seeks the lowest point, spreading out under gravity until it forms the flattest surface possible. After the impact that formed reshaped, the basin was quickly filled with molten rock, which then cooled into the smooth plain we see now. But where did the lava come from? There are two main theories. The first is that the impact cracked Mercury's crust, allowing magma from deep underground to seep upward and flood the basin. The second is that the impact itself generated such intense heat that it melted the already hot crust, producing what is called impact melt. The true explanation may well be a combination of both. Once we understand this pattern, rough edges, smooth interior, we start to recognize it elsewhere. Craters like Rustaveli Copeland and Polygnotus all show similar signs of lava flooding their interiors. Then there is Rachmaninoff, a particularly intriguing case. Inside its basin, we see not only smooth plains but also circular cracks, almost like wrinkles in the crust. These features suggest magma didn't just pour in once. Instead, it slowly pushed upward in repeated surges, cooling, cracking, and then rising again under the influence of Mercury's fluctuating temperatures. From these craters, a picture emerges. Impacts from space didn't simply scar Mercury. They often unleashed the volcanic fury hidden within. Lava on Mercury wasn't confined to impact sites. One striking example is Angkor Vallis, a valley where we can still see signs of lava flowing like a river. The molten rock poured downhill into a nearby basin, moving as a fiery current across the surface. Over time, such flows filled vast seas of lava, coating immense regions of the planet. These seas cooled into broad plains that now appear more orange than the surrounding terrain. Scientists recognize this color difference as a telltale sign of ancient volcanic activity. The story became clearer in 2015 when NASA's Messenger spacecraft passed over one such area northeast of Rachmaninoff. Its instruments detected that the surface was covered in a fine dust. Careful analysis revealed this was volcanic ash. The ash must have been ejected explosively from vents, then settled over the land like snow. Except this was no gentle snowfall. NASA scientists described it as fiery, hot, angry snow. So Mercury wasn't just a place where lava crawled across the ground, it was also a world where volcanic ash could rain from the sky. The most dramatic evidence of Mercury's volcanic past comes from a massive crater called Navoi. At 66 kilometers across, it is enormous. But when scientists studied it closely, they realized it was not an ordinary impact crater. Typically, when a meteor strikes a solid surface, the walls collapse inward and debris slides into the center, creating a raised central peak. The shape depends on the angle of impact, but the process is consistent. Navoi, however, doesn't fit this pattern. Its central structure is not the rounded or teardrop-shaped peak we would expect. Instead, it shows signs of having been carved out from below. The conclusion: Navoi wasn't formed by a rock from space. It was blown open by a massive volcanic eruption. The force required to excavate such a basin would have been extraordinary enough to blast rock outward for kilometers in every direction. Imagine standing on Mercury during that eruption. The ground beneath you rips open and an explosion of molten rock ejects so violently that it reshapes the entire landscape. Navoi tells us that Mercury's volcanism wasn't limited to slow lava flows or moderate eruptions. It could also erupt with catastrophic violence, hollowing out entire regions of the planet. Today, Mercury is quiet. As far as we can tell, there are no longer any active volcanoes. The sun still bakes its surface, but the furious activity beneath has cooled, leaving only silence. Yet, if we know how to look, the scars remain. Smooth crater floors, wrinkled basins, valleys, coated with lava plains tinted orange, and giant volcanic vents like Navoi. All of them are written into Mercury's geology like chapters of an ancient book. These scars tell the story of a time when Mercury was alive with fire, when the surface itself melted, flowed, and exploded. They remind us that even a small, seemingly barren planet can have a history of unimaginable violence. So the next time you look up at the night sky and spot that small, elusive dot close to the sun, remember, you are looking at a world that once melted a planet that turned itself into a sea of lava before finally settling into the quiet rock we see today. Mercury may be quiet now, but its scars remind us of a violent history that shaped the solar system we live in today. By studying these worlds, we not only uncover their stories, but also gain a deeper understanding of our own planet's past. If you enjoyed this journey, don't forget to join us again here on Cosmic Compass, where we continue exploring the cosmos, one mystery at a time. And here's a question for you. If you could visit Mercury during its molten age, would you dare set foot on its lava plains? Let us know what you think in the comments below. Until next time, let's keep looking up and keep navigating the wonders of the universe together.